The solution to batteries. This is something we all really need to know, all of these wonderful projects around the world, but the big issue, the big question mark at the moment is storage. What can we do here? And if we could get the storage situation solved, we'd all be very move our business a lot more rapidly, and we'd be a lot happier in this industry. I'm very happy now to have with us the head of Global Renewable Solutions for ThyssenKrupp, a gentleman that looks after the growth of utility, large-scale flow batteries, electronic hydrogen, renewable ammonia, and renewable chemical products for ThyssenKrupp. Of course, the mega engineering outfit coming from Germany. So a very warm welcome, please, for the head of Global Renewable Solutions, ThyssenKrupp, Dr. Christopher Papal.
Thank you very much for that wonderful introduction. It would be great if people could stay. We have a wonderful renewable energy storage to talk about now. Okay, thank you very much to those who have stayed. Assalamu alaikum. My name is Christopher Papil, and I'm talking about energy storage today for ThyssenKrupp. And I've had many discussions with you, many of the people here at the conference in the last 2 days about energy storage. And today, we've spoken about the synergy between photovoltaic and energy storage, redox flow batteries particularly. And what I want to say today is really that photovoltaic is like the right hand and energy storage is the left hand. And together with two hands, only can you do heavy lifting. So to do the lifting in the heavy industry that ThyssenKrupp is known for, we need to have energy storage for making photovoltaic and all renewables integratable into the grid. Okay, thank you. So as I mentioned, ThyssenKrupp is very well known as a heavy industry company, but we do a lot more than steel and heavy industry. But I want to give you a profile to give you a sense for who we are. So basically, ThyssenKrupp is over $45 billion revenue a year company, so we're a very large company. Our group, ThyssenKrupp, also includes UDA, which many of you know here in UAE. And we have a lot of patents. We're a technology company as well as an EPC company. We're in 80 countries, and we have over 155,000 employees, a lot of engineers around the world, 80 countries. So the challenge is for energy storage that the grid has very fast ramp up and ramp down, and that's made even more difficult by adding renewable energy. So even without PV, we would need to have some kind of energy storage, but with PV, it's even more important. And also, as we add more and more renewable into the system, we don't want to have to be curtailing or throwing some of that away. We can, of course, everybody knows, shift the PV supply in the daytime to the nighttime requirements, and there's a lot of ramp down happening late at night that happens too fast for thermal power plants to take care of. So the solution for that is some sort of energy storage system, and I want to talk about today is ThyssenKrupp's solution, which is both a combination of vanadium redox flow battery and also our electrolytic hydrogen that we used for long-term energy storage as a vector for that. So when you put these two things together, you can maximize the asset value of the renewable energy for PV or wind or whatever you may want to be putting into the grid. So what we actually bring specially to the situation is ThyssenKrupp chlorine engineers have for many decades been the leader, and we are the leader currently in making the electrolysis of brine water to hydrogen, chlorine, and caustic. But we use the very large cells that we've developed in those systems, and we have decades of experience, and we apply them to vanadium redox flow batteries. And we have by far the largest cells that are available, called supercells here in this presentation. And that means that we can handle very large projects. So that the image there you see of the flow battery, those are container size greater than megawatt power of electricity, each container, a 20-foot container. And the center two tanks are where we keep the hours of storage, which is in the form of vanadium itself. So this is a very flexible system, especially when you add it together with hydrogen, because if there's a demand drop on the weekend or a demand drop when there's a seasonal change or for a long period of time, we can handle that with hydrogen. But if a day-by-day basis, the flow battery is able to give us 4 hours or more of energy storage and really handle very fast ramp up and ramp down, which is needed to have some virtual inertia into the system. So our company, of course, we're a German company. We have global expertise in many, many projects around the world. We have over 500 electrochemical plants that we have developed, and our technology is used, and we've done the EPC or provided the technology for those electrochemical plants. So that's really a world leader. That's a lot of experience. 70 locations, so we're actually the #1 supplier of electrolytic hydrogen in the world because our chlor-alkali plants make electrolytic hydrogen. And we have over a century of experience, actually nearly 200 years. If you use vanadium redox flow batteries as opposed to lithium-ion batteries, then you have the added advantage that our vanadium in our system is nearly 100% recyclable, so it's very good for the environment, and you can recoup the cost of the vanadium at the end. So as mentioned, we have over 10 gigawatts of installed capacity. So I had just a very short 5-minute presentation today. I invite any of you to come to see me after the presentation. If you see me in the hallway, I'd love to talk with you about what we can do to help your PV projects or your grid projects. And as you can see by these blue dots, ThyssenKrupp is in many locations in MENA and around the world, of course. Thank you very much for your listening.